Hello, good morning, good evening, good afternoon, everybody. Welcome to SUSECON this year. My name is Jan Krüger and I'm joined by Alessandro today.
Hi, everyone.
We are going to share with you today how Intel OneAPI is going to help SUSE and you at the end of the day to really accelerate and execute on your AI projects. So let's get started. Today it's all about data. And the industry has been talking a long time about the flooding of data, which has been coming and is continuing to come in the next couple of years. Everything we do at Intel is really centered around designing and building products to process, store, and analyze this data, and how to break through the barriers of the increased complexity, and even furthermore, how to harness the data and drive value out of it. Given the growing demand for AI and ML, Intel is offering a wide range of products which are supporting you on this journey. Important to understand is the fact that the type of data and how it's been structured is driving the work for your data scientists. There's also a growing importance of data location, which is driving the data's time to value. And that's by far the biggest challenge, how to improve and optimize the data's time to value. We can build solutions to analyze and make recommendations. But if the latency is too high, then the ability to leverage the insight of that data can be lost quickly. So, delivering solutions that enable companies to harness the data more effectively and efficiently is our focus. Intel knows the data center and knows what's required to optimize across the network, the storage, compute, and software. We have been on a journey to build out a broad portfolio of differentiated and leadership solutions to address customer fast evolving needs. In the connectivity space, we are delivering solutions from standard Ethernet to high performance Ethernet switches to industry leading silicon photonics, clearing the path for solving the throughput and latency as well as power requirements of the future. In the storage space, we've innovating with Optane to bring more data than ever closer to the point of computation. We've expanded our processing portfolio with continued innovating on our Xeon CPUs and expanded our XPU capabilities that are including FPGAs, ASICs, and GPUs, especially designed for AI workloads. As well as we are delivering a wide range of software products enabling and unleashing the power of the underlying hardware. So, what are the challenges now really to make use of all those solutions and how to leverage the underneath capabilities through software in your solutions? So, well, there is a programming challenge. As Intel started that journey, that challenge became very obvious. Today, each kind of data centric hardware needs to be programmed differently, using different languages and libraries, requiring to maintain a separate code base as well. In addition, inconsistent tools supporting the different platforms or cross platforms means developers have to waste a lot of time to learn these different tools, these different tool chains. That also means software developing is becoming much more complex as each hardware requires separate investments, with little ability to reuse the work targeted at the different architecture. So, in order to address this problem and this challenge, the OneAPI industry initiative was created. It is delivering a unified software development environment across CPUs and accelerator technologies. The OneAPI industry initiative is based on standards and open specifications. It includes a unified language and libraries that deliver a full native code performance. It delivers native code performance across all hardware, including CPUs, GPUs, FPGAs, as well as AI orchestrators. OneAPI is the foundational programming stack which is used to optimize middleware and frameworks and sit on top of it. And it's including frameworks like TensorFlow. We will come back to this a little bit later. And based on those open specifications, Standards are driven cross-vendor and ensuring compatibility across vendors as well. So this is by far only an Intel play. That is really an industry-wide initiative to resolve this never-ending story around programming specifically for specific hardware components. So Intel's product at the end of the day is a reference implementation of the OneAPI initiative. It includes advanced porting and analysis and debugger tools that span from the networks across the network stack. You can debug, you can analyze, you can optimize your code at different levels in the stack. It also enables you to reuse code across the different architectures and different vendors. So how do we achieve that? That's achieved through a standard-based new programming language called Data Parallel C++. Data Parallel C++ is a high-level language designed for data parallel programming. It's based on C++ language for broad compatibility. It provides a full native high-level language performance on par with standard C++. It simplifies the code migration from proprietary languages with programming models familiar to GPU software developers. Starting Point is a SUSECON standard being developed under the industry group consortium of the Kronos Group. Intel has addressing the gap in those languages through additional extensions which had been driven into the standard. It includes open source code it provides open source code to open source code compatibility tools, let's say, to assist with migrations from other frameworks like CUDA to DPC++. We are also leveraging the well-proven LLVM compiler technologies, as this has a long history with Intel as being the leadership on the compiler side. And there will still be opportunity to optimize the platform along the way, and Intel is committed to implement those optimizations for the various hardware products coming out in the next couple of years. So switching gears now on how you can make use of that. Well, let's begin first by looking into the overall AI software stack, with all the different layers and the different personas using those different layers in a different way. The lines between those personas as well as the stack itself is sometimes blurred, as nowadays you have experts which are ranging from software development through data scientists, or you have data scientists crossing over to performance engineers. But in general, a performance engineer drives for optimization of mathematical operations for the various hardware components. So it uses specific libraries and develop and optimize those libraries for the underlying hardware. A data scientist, in contrast, creates a topology and the models being used, and it's used to harness the optimization of the machine learning performance engineering department as well. So it's basically using the underlying layers for better outcomes. Software developers develop tools and services which are enabling other app developers at the end of the day to build software on top of it. And the app developer is really the one who's using those pre-trained algorithms or using pre-trained or pre-set up software components to build a solution at the end of the day. And well, Intel OneAPI and the OneAPI initiative is addressing the entire spectrum of this stack. So how does it work? From Intel's point of view, OneAPI software stack spans vertically from the kernel to the developer tools and horizontally from machine learning through management tools. Alessandro will talk a bit later about further challenges in the setup from using management tools and DevOps in conjunction with data scientists, but I leave that for him for later. For an ML performance engineer, Intel provides OneAPI compliant drivers and libraries, like our Intel Math Kernel library. Or for deep learning, we are providing our Intel Math Kernel library for deep neural networks. And those libraries enable the performance engineer to further optimize those for other platforms, or use those for Intel platforms to gain the best performance. For data scientists, Intel is providing the frameworks like TensorFlow or PyTorch for deep learning, or for machine learning, distributed Python, with the inbuilt optimizations from the underneath layers. So if you're a data scientist, you don't need to optimize your framework towards the platform. You can use the Intel provided TensorFlow frameworks and start right with those and gain all the optimizations which had been introduced through the underlying layers. For app developers, we even go a step further. For app developers and platform developers, we are delivering the analytics zoo, for example, which is providing sample data and models to validate your underlying stack and validate those in terms of performance and throughput and other KPIs. We're also providing solutions on top of those, like OpenVINO, which is particularly designed for deep learning, processing, and inference. Let's map now what exactly the Intel OneAPI Toolkit delivers and how we bring that to market. The OneAPI-based toolkit is including all the libraries for machine learning and deep learning performance engineers. So that's where you start by optimizing for the platform. The OneAPI framework developer toolkit is including only the libraries for deep learning purposes. The OneAPI AI and Analytics Toolkit is for our data scientists to use Intel optimized TensorFlow or PyTorch for machine learning or deep learning. At last, the OneAPI OpenVINO is our solution for software and app developers. And as you can see, we are providing a wide range of toolkits pre-packaged to consume in your software products. So by looking at the whole set of OneAPI toolkits we are providing, we started with the base toolkit, which is really about using or deploying certain optimizations for your platform. We're having then those domain-specific toolkits as add-ons for high-performance computing or for IoT in particular. And we have toolkits which are powered by OneAPI for our data scientists and AI developers, like the AI Analytics Toolkit. That brings me to our collaboration with SUSE. SUSE and Intel had been looking into how we can resolve the problems in the market around AI, DevOps, and between DevOps and data scientists. And I will hand it over to Alessandro now to talk about SUSE FuseML, which is using the Intel AI Analytics Toolkit out of the OneAPI framework. Over to you, Alessandro.
Thank you. Thank you very much. Yeah, as you said, well, let's see how we collaborate together actually to try to solve the most common problems that the DevOps have these days. And I'm starting from here, basically to say how can we move from innovation to product and how Intel and SUSE may help the AI community or the AI practitioner to that. Well, actually, we have three main goals. One is to reduce the complexity of the AI projects. The other one is to optimize the outcome of the developing AI models, how we can optimize them, how we can make them more performant, more precise, more accurate when it comes, and possibly in an easier way. And finally, simplify the end-to-end life cycle. It's not just about training, it's also about inferences, those models. So let's show and deep dive our collaboration. And to do so, basically do a better definition of ops these days. We used to define them as a DevOps. DevOps is someone that actually has coding capabilities, coding knowledge to automate all the things, but also is responsible for the operational part of infrastructure, how to operate infrastructure. And you give a lot of definition and use cases in the first part of this presentation, how Intel actually can help DevOps through the stack of capability they offer. But I want to deep dive a little bit more than that and try to define a better definition, the ML ops and the AI ops, where with the AI ops, we simply identify those ops, those operational professionals that actually leverage AI as part of their existing infrastructure, as part of their existing tooling. So these people are not necessarily AI practitioners, are more people that leverage AI as a part of their existing tools without actually knowing that they are using AI, not necessarily at least. While MLOps, that is our focus in this presentation, are those practitioners, those operational professionals that actually leverage machine learning. They are AI practitioners, they have a good understanding, a good knowledge about that, and they are responsible to build and run this end-to-end machine learning lifecycle, from the data gathering up to training the model, up to serving the model to the inference. So there is pretty complex scenario where actually you have not just to glue together the various pieces, but also to optimize them. So we can identify then more or less three kind of professional within these operational teams. And the collaboration between Intel and SUSE is, as the definition says, for operational teams who need to have a way to build, automate, and monitor any type of workload. So starting from data gathering, the personas we identify as the data engineers, up to the machine learning operators is a HOP, is an IT op responsible for the productization, the deployment, and the inference of AI workloads, up to the classical DevOps definition. That is more focused on monitoring, auditing, getting the metrics out of this end-to-end pipeline and understanding how it runs. If it can be done something at the infrastructure level that can optimize this pipeline. So if we go down deep dive into this life cycle, we observe that those three personas need to collaborate together. And they need to collaborate with the data scientist team. And as you were describing before, each one of them basically has their own tools, their own needs. And that makes the life of a machine learning operators pretty complex. Data scientists maybe want to use MLflow, for example, as a tool, or specific tools like Pachyderm or Allegro to train, to build a model, to training, to track them. The data engineer maybe want to use some other kind of tools to build the data sets. And finally, when it goes to inference, you want to probably use Intel inference engines, or sometimes you are using some other tools where you want to integrate the inference engines there. Now, the problem is that all those tools are not meant to work together. It's not that easy to integrate one to each other and makes your life pretty complex. So the idea behind that actually is to create a sort of recipe. And the recipe is a way to glue together those tools, removing the complexity and allow you to focus on what is matter. How do I optimize the training model? How do I optimize the inference engine? How do I serve this thing without actually changing the life of my data scientist team? And FuseML, the FuseML project, it goes exactly in that direction. But the collaboration with Intel was allowing us, SUSE, to leverage the Intel AI toolkits and the Intel capability when it comes to AI to create an optimized version of this vanilla recipe to speed up the entire life cycle. And I will go through a really small demo to show how actually we manage that. So let's go for a demo, because as usual, see things is better than describe them. For the sake of this presentation, I'm going to use a recording video of this demo just because otherwise it would take too much time to go through each steps. So FuseML is a simple tool that allows you to install from the way you collaborate with your teams, GitHub style, GitOps approach. That means you can use GitHub, GitLabs, any Git repo, compliant repo. But if you don't have anything, we provide you a local version of it, call it Gitty. So when you log in there, you have your own workspace, you have your own repos, you can collaborate with that. In our case, for example, we are going to run through the FuseML demo playground. We have different kind of example. What we're going through today is what we call it the wine example. What is the wine example? It's a simple logistic regression where we train a model to identify the quality of a wine. So we try to basically play the role of a company, winery.co, with a team set up that need to solve these use cases. If we go for production of the wine, are we sure that this wine is the right quality before going to production? To optimize the entire cycle and put on the market something that actually our customer will love it. So we have a team here that actually working there. We got Sasha, the data engineer responsible to gather the data. We got Michael, the machine learning operator. This is the most important person here that actually responsible to build and glue this end-to-end pipeline. We also have Jean, our data scientist. She's responsible to build the model. And finally, we have Alex, a full stack developer that actually is responsible to create the smart app that the winery co-professional can use to understand the quality of wine they are going to produce. So the first step is that basically um, Alex developed a smart app. But of course, this smart app is expecting to have an inference model that actually can allow him to run it and to do the predictions. Now, if we open the smart app right now, we try to predict that, we will get an error, a 404. There's no model there. There's nothing there. Now, think about it for a minute. What I already said is already quite complex. I already give for granted that we can able to pick up the data, that we can able to hook up the data to the model that Gene developed, that we can train the model maybe even more than one time, maybe making some optimization that we'll explain later, like using the Intel recipe instead of using a vanilla recipe, using an Intel optimized TensorFlow framework instead of using the standard TensorFlow. Then once we are satisfied with the training of this model, we need to hook up, we need to serve the model to the inference engine. And the inference engine need to be exposed and hooked up automatically to the smart app. It's pretty complex pipeline. It need to be maintained because the model over time will lose precision. Maybe we will develop a new version of a model. Maybe we will slightly change some parameters on the inference engine. So all these steps are typically manual steps, takes a lot of time and are exposed to a lot of human errors. But we are within FuseML, so we can actually automate all the things. So everything we have to do is simply do a command like FuseML push, give a name of application, wine, point it to the folder, the GitHub folder or the local folder where you are, the clone of the repo you have, and just execute it. FuseML will take care of all the sources, will create the information up to the Kubernetes cluster, will start to issue this application so that actual application will be served to the Tecton pipelines that we use as engine. Maybe it could be Argo workflows as well. And then we start to build the containers that will execute all the steps for us. As you can see, I'm not touching anything. FuseML is doing everything automatically for me. It's taking care of everything there. And also, it's exposed everything to, in this case, MLflow, so that the data scientist can even see the results of the training and decide if need to rerun the training, if they need to change parameters, and etc. And whenever it does these changes directly in the repo, a new pipeline will basically issue. You see that? The pipeline is there. I got all the metrics that I need. I got everything that I need there. I can literally evaluate that. Now, in this case, this is the first example. There's one single run, so there's nothing more than that. But basically, I can go there. I'm not really satisfied, so maybe I want to apply the recipe. All I need to do is basically just slightly change one line of code in my training model, like using the TensorFlow, and FuseML will take care of everything else. And finally, we already automated publish everything here. So that means that basically my apps become smarter and I can literally predict the outcome. So as you can see, the four personas were collaborating together without even see the complexity of all this end-to-end pipeline. Now, what is happening when I apply the intercept? Let's take the example we got and see the results after we apply the recipe from Intel. Now, you can see that in the vanilla recipe, we had certain accuracy in the training model. Simply apply a different recipe. They said, hey, use the Intel Toolkit instead of the vanilla one. Use these Intel optimized frameworks instead of vanilla framework without having changing any line of code. We get way better results than that. Now, that means that I, as a data scientist, only care about writing the model. I, as a machine learning operator, only care about building the steps in the pipelines. And then I simply apply a pre-optimized recipe from Intel that will take care of everything else. Will take care to boost my prediction, to boost my entire life cycle up to the next level. And that's the beauty of FuseML. Now, FuseML is an open source project, as everything we do at SUSE. Is open to contribute, is open even to be used, and so we can receive feedback. And I strongly suggest everyone that sees this presentation actually to reach out to GitHub FuseML repo and start collaborating with us and let us know what to do. And with that, I'm basically moving back to Ian to conclude the session. Back to you, Ian.
Thank you, Alessandro. That was very, very helpful to see how FuseML enhanced with the Intel OneAPI toolkit can really help you to accelerate the output. And that's what I said at the beginning of that presentation. It's all about the time it takes to get meaningful information out of the data. If you are able to accelerate this time to value, you can gain real value for your company or for your customers out of the data you collect. With that said, please also visit intel.com if you have further information on OneAPI, because there, as I've been outlining, many different toolkits, as well as I'm inviting you to try out FuseML, which includes these optimizations we've been talking about, and look out for more innovations we are driving in this field. With that said, thank you very much for your time. Thank you, Alessandro, for joining me, and have a good day.